Space travel, a milestone in the development of human exploration. While of course the rockets created themselves are very complex and impressive, part of our ability to leave this planet and explore the universe comes to luck. Imagine if Earth's gravity was so strong that our rockets just couldn't escape. Well, on other planets, that could be a possibility. First, let's talk about the exoplanet escape factor. The exoplanet escape factor is a concept proposed by Elio Quiroga, a Spanish professor who proposed this concept. The exoplanet escape factor is a theoretical metric indicating the difficulty for a civilization to leave their homeworld. Our planet has an escape factor of 1. If a planet were to have an escape factor of 2.2, space travel using our conventional chemical rockets would be impossible. Now that we know that, how can we escape these high factor planets? One idea is to launch from a very tall mountain. If our planet had a super tall mountain, similar to Olympus Mons on Mars, maybe we could get enough height to escape. Unfortunately, no. Escaping the planetatial's gravitational pull requires you to be a certain speed rather than starting from a higher elevation. At the end, you would just fall back down. Also, because of the high gravity on the planet would have a thicker atmosphere, making it even more difficult to escape. Another method could be using a mass driver, which is basically a giant electromagnetic catapult to launch a ship with tremendous speed. I will admit it's an idea I thought of myself as well. Speed up a ship in a circle before quickly releasing into space. While this could possibly work for satellites or cargo, it may not be as effective for rockets with humans in them. The speed the mass driver would have to reach to launch a ship like that off the planet could be way too fast, too much for the crew to handle. Plus the air resistance from the extra thick atmosphere of this planet would likely just flatten the ship completely. One last method I'll give is nuclear thermal propulsion. This method goes straight to upgrading our rockets themselves. On Earth, these fuel-powered chemical rockets work great, but on a planet with super high gravity, the amount of thrust the rockets give is too weak, considering the weight of all its fuel. Rather than burning fuel and causing combustion, like our chemical rockets, nuclear thermal propulsion rockets have a nuclear reactor in order to cause nuclear fission in order to create thrust. These rockets may be more powerful to escape some planets that our chemical rockets couldn't. Here on Earth, there's always been debate about the use of nuclear power and the cost of such, but on a planet where chemical rockets wouldn't even work, these might be considered. In the end, these are all just theories. We live very early in a year where space exploration is still very new. I wish to have one day seen all the beautiful things in space. One day, we'll be able to land on supergravity planets with rockets that are also very powerful enough to leave them. One day, humans will explore space, but till then, we live in our very little planet Earth.